lab on this. I have a video lab already set up. Okay, so drawing ray diagrams is kind of like with lenses, but different. So instead of bouncing off of the mirror, ray diagrams is kind of like with mirrors, but different. Instead of bouncing off the mirror, it has to bend through the lens. Okay, so they look something like this, and it's going to vary depending on where the object is. Where the object is relative to the focal length will determine where the image is and how big and what type of image you get. Okay, so the first step in drawing a ray diagram, this is line 1. What you want to do is draw a line parallel to the principal axis from the tip of the object through the lens, or to the lens. Okay, then you continue that line, it bends, and you draw the line from the lens through the focal point, just off into space. Okay. And you're not going to know where the image is going to be produced yet, so you just continue the line on. Then the second one is this line right here, where you draw from the tip of the object through the middle of the lens, and then just keep going. And now you know where those two cross, you're going to get an image, but we need a third line as well. You can actually get the image spot from those two lines, but the third line helps you to complete the ray diagram. Okay. So the third line you draw from the tip of the object through the focal point to where it crosses the lens, and then you continue that. It bends so that it becomes parallel, and it should cross where these other two cross. Now you have the image, where the image is, and you should be able to tell what type of image it is. So now you draw the arrow, and this arrow just represents what the object is, whether it's a candle or a flag or what, a person, and then this would be the image. Okay. So turn to your neighbor or tell yourself, what type of image is this? And since it's upside down, you should know that it is a real image. That you could then put a screen right here and be able to tell how big it is. So it's larger than the object, and it's a real image. Okay, we're going to skip that. So if the object is at the focal length, so if you put a candle right here and one focal length away from the lens, then you could actually project this onto a screen as big as you want, and that's how film projectors work in movie theaters. If you have the object a little further away, but not too far, it's between f and 2f, then the image is enlarged, and it's still a real image. So you'd be able to catch it on a screen, but it's only going to be like 1.5 times the size of the object. Then if you put it at 2f, then the image is at 2f. If you put it a little farther than 2f, then the image is between f and 2f, and it's smaller than the object. And then if you put it infinitely far away, is what we say. So if you're focusing on something that's really far away, like say mountains, and you have a darkened room, you can take a magnifying glass and get an image of those mountains that's really small. And that's the first step we're going to do in the lab we're going to do tomorrow. Now, what if the object is closer than f, closer than the focal length? Well, that's when you're actually using the lens as a magnifying glass, so you can see the image is enlarged. Now, remember these diagrams. If you want to get the bonus points, you can actually draw these for each of the scenarios in the lab for extra credit. Okay, so image formation. This pool water is actually giving this convoluted image formation. It's acting as a lens for the bottom of the pool. Binoculars, the way that they enlarge the object is to use convex lenses here and here, the eyepiece, and they use prisms to turn the image right side up. Otherwise, the image would be upside down and backwards. A camera works much like the lens of your eyeball. It focuses the light from the object to the film where the image is produced. And this is how a telescope works. And microscope. Telescopes and microscopes are very similar. And a projector.